Welcome. On this video, we're going to be showing how to solve rational equations. So let's get started. So some things to remember along this lesson is that the strategy that we'll be using is that we want to make sure to have all denominators of the rational functions to be the same. We're going to call that the LCD, and we're going to show that in a second. And whenever we are solving rational functions, we also have to check for what we call extraneous solutions. So let's apply these things to remember in some examples. So on example one, what we want to do is we want to solve the equation algebraically. And again, I can see that there are some rational expressions here, therefore it's a rational function. Therefore, we have to check for extraneous solutions. So let's get started. So the first thing that I would like to do anytime I want to solve for rational functions is that I want to check for the LCD. So to check for the LCD, there are two things that you will like to do. First, take a look at all the denominators in all the rational expressions. Here, we have two different expressions as denominators. We have the expression of y plus 1, and we have the expression of y, because notice that the third fraction, it also uses y minus 1. So therefore, there are two expressions, y minus 1 and y. So if I combine them two, if I combine all the possible expressions on my denominator, I'm just going to call that the LCD. So now that I have finally identified what the LCD, my job is to make sure that every fraction has that LCD as denominator. So how do we do that? Well, let's just rewrite the function that we're trying to solve here. So y minus 1 equals 8 over y plus 1 over y minus 1. So the way that I want to do that is I'm going to take a look at one fraction at a time. So let me take a look at the fraction on the left hand side. I have y minus 1. So what is my denominator missing from the LCD? Well, it is missing the expression of y, and therefore I'm going to multiply y on the top and y on the bottom. Because that way, if I multiply them, I'm going to have y times y, well, that's y squared. And now the denominator is going to be y times y minus 1. And notice that now I have the LCD. And I want to make sure that all denominators have that LCD. So I want to take a look at my second fraction. My second fraction has a denominator of y. So what expression am I missing? I'm missing y minus 1. So therefore, I'm going to multiply y minus 1 on the top and y minus 1 on the bottom. And if I do that, on the numerator, I'm going to have 8y minus 8, because this 8, it gets distributed. Now on the denominator, I'm going to have y times y minus 1. Let me just rewrite what it's on the top. It was not that clear, but we still have the same 8y minus 8. And now notice that these two fractions have the same denominator. And I'm going to do the same for the last one. My denominator is y minus 1. So what am I missing? I'm missing a y. So therefore, I need to multiply y on the top and y on the bottom. And by doing that, now I have y on the top. If you distribute, 1 times y is y. And on my denominator, I have y times y minus 1, which is the LCD. So notice that now all fractions, all the denominators in every single rational expression have the LCD. And once I have that, I want to simplify this as much as possible. So now I can see that on the right-hand side, I have the same denominators. So therefore, I can just combine the numerators. So I'm going to have 8y minus 8 plus y all over y minus 1. Let me simplify this a little further. So now this becomes y squared, denominator y minus 1 equals, combine like terms, so I got 9y minus 8 all over y minus 1. And this is good, because now that we have it in this form, it is here where my denominators are going to cancel out. And the reason why they cancel out, and you can verify yourself, you can just cross multiply and then divide by that expression, they're just going to cancel out. So we're just going to cancel out right away. And this is why we wanted them to have the same denominators. Because once you have the same denominator on the left and the same denominator on the right of an equation, they're always going to cancel out. And now that they cancel out, notice the type of equation that we have. I have the equation y squared on the left and 9y minus 8 on the right. And now I want to solve for this. So if I solve for this equation, it is equivalent to solving for the original. But this equation is easier to solve since there is no fractions involved. So let's just solve for this. Let me just make it equivalent to 0. So let me subtract 9y. So now I have y squared minus 9y equals negative 8. Let me add an 8 to it. That cancels out. So now I have y squared minus 9y plus 8, and this is equivalent to 0. So now notice that this is a trinomial whose highest exponent it is 2. So let me see if I can factor it out. So notice that that expression can be factored out as y minus 8 times y minus 1, equivalent to 0. Negative 8 times negative 1, it is positive 8, so that's good. Negative 8 plus negative 1, that is negative 9. So that's good. So now, if I solve for them individually, I'm going to have the first expression equivalent to 0 and the second expression equivalent to 0. So if I solve for it, so let me add 8 on both sides. I have that one solution is that y is equivalent to 8. And my second solution is that y is equivalent to 1. So now you might be tempted to just say, well, yes, these are my solutions, so I am done. But notice that we always have to check for extraneous solutions. Now, when it comes to rational functions, extraneous solutions are solutions that make my denominator equivalent to 0. And notice that here we have one extraneous solution. Let's see what happens if we let y be equivalent to positive 1. Well, if we let y equivalent to positive 1, notice that if I were to plug it into this fraction, I'm going to have 1 minus 1, which is 0. So by plugging in y being equivalent to positive 1, I have a denominator 0, which is going to give me an undefined number on the left-hand side. So therefore, I cannot use the value of positive 1 as a solution. So this is what we refer to as an extraneous solution. So we just ignore it. Even though algebraically we got a result, it doesn't work with the equation that we were given. So this is what we call extraneous solution, since it made the denominator equal to 0. You only need one denominator to be equivalent to 0 in order to exclude that solution. So just for formality, let's check for 8. So if I plug in 8 on this denominator, that is equivalent to 7, which is good. Plug it in here, denominator of 8, which is good. Plug it in here, denominator 7, which is good. So I don't end up with any denominators being equivalent to 0. So therefore, my true solution it's only when when y is equivalent to 8. And notice that essentially what we did, we just made all denominators have the same expression called the LCD, and then I solved for my new equation. Let's take a look at another example. So same idea here. I want to take a look at my whole equation, and I want to identify all denominators. So let me get rid of this. Okay. So now that it's out of the way, let's continue with example B now. First thing that you want to do is take a look at my denominators. I have 2n, I have n, and I have 4n. So therefore, my LCD, it is equivalent to just 4n. But wait a minute, I just told you that in order to find the LCD, I just group all expressions? Wouldn't it be the LCD 2n times n times 4n? Well, that is definitely a common denominator, but it's not the least one. Because even though they all have different expressions, notice that they all have the same variable, n's. It's just one single expression. It's just n. So the reason why I'm calling for n to be my LCD is because my objective is to have all denominators be written the same. But notice that 2n, if I multiply it by 2, I'm going to get 4n. The expression of n, if I multiply it times 4, I'm going to get 4n. The expression of 4n, it's already 4n, so there's nothing to do. So notice that 4n, it's an expression that I can make all my denominators be written as. I just need to modify it a little bit. And that's actually what we're going to be doing now. The objective is to have all denominators be written on the same format. So let's just write it in the least or the simplest form. So therefore, this is not my LCD. I'm just going to make it 4n. So let's just do that. So 1 over 2n equals 1 over n minus n minus 3. So all I did, I just wrote down the expression that we're given. And again, I want to make sure that all denominators are written by the LCD, which we already decided to be 4n. So if I take a look at this denominator, I have 2n. So how can I make it equivalent to 4n? Well, I can just multiply 2 on the top and 2 on the bottom. And by doing that, now my new expression is 2 over 4n, which is good. Let's move on to the next one. I have an expression of 1 over n. So what is the denominator missing to be 4n? It's missing a 4. So therefore, I'm going to multiply 4 top and bottom. So by doing that, my new expression is 4 over 4n. That looks like a 9. Let me just rewrite it as a 4. Now, the last term, notice that it's already written in terms of 4n. So I'm just going to bring it down. So now it becomes n minus 3 over 4n. And now that they all have the same denominator, let me just try to simplify this. So the right-hand side is still 2 over 4n. Now we got to be careful with how we're going to simplify this, because notice that this negative, it's affecting the whole expression. It is not just, this negative is not just affecting the n. This negative is outside of the parenthesis, outside of the fraction, so therefore it's affecting everything. So one way for us to think about it is that that negative, you're just going to change the signs of the expression on the top. So instead of positive n, it becomes negative n. And instead of negative 3, it becomes positive 3. Now that they have the same denominator, I can just write them all under one denominator. So let me just simplify this a little bit further. 4n, simplify this, I get minus n plus 7 divided by 4n. And this is what we wanted. I wanted the right-hand side, the denominator of the right-hand side, be equivalent to the denominator of the left-hand side. Now that they have the same expressions, they're going to cancel out. And all I got to do now is just set the numerators be equal to each other. So 2n on the left minus n plus 7 on the right. And all I got to do is just solve for n. So to do that, let's take away 7. That cancels. So now I got negative 5 equals negative n. Let me divide it by negative 1. That way the sign cancels out. So now I have that n is equivalent to just 5. And again, whenever we are solving rational functions, we always want to check if we have extraneous solution. So let's check if 5 is going to give me a 0 in the denominator. Plug it into the first denominator, that gets me 10, so that's good. To the second, that gives me 5, so that's good. To the third, it gives me 20, so that's good. So notice that 5, it will never give me 0 in the denominator, so therefore, that is my solution. So my solution is that n is equivalent to 5. So notice that the idea here, it's always the same. Make sure that you write your fractions using the same denominator, because they will cancel out. And once they cancel out, you just work out with your new function or equation. So let's take a look at one more example. And notice that this example, it looks a little more complicated. So the idea is still the same. I want to make sure that all denominators have the same expression, the LCD. But before I start taking a look at the LCD, try to see if you can factor any of the denominators. And notice that that is possible on the last expression. So let me just rewrite this. So we still got x minus 4, 1 over x plus 3, 28 on the top. But now notice that the expression x squared minus x minus 12, I can just factor it out as x minus 4 times x plus 3. And now that I have properly factored out the denominator, now I can start thinking about the LCD. So what is my LCD? Let me take a look at all the expressions on the denominator. I have an expression of x minus 4. So let me make it part of my LCD. I have the expression x plus 3. I have the expression x minus 4, but we already wrote it here, so there is no need for us to repeat it. And I also have the expression x plus 3, the same idea. There's no need to repeat it since I already have it here. So therefore, this is my LCD. So now that I have properly defined what the LCD is for this equation, let me move on to the next step, where again, the next step is to make sure that all denominators have the same expression, aka the LCD. So let's take a look. X over x minus 4, what is my denominator missing? Well, my denominator has an x minus 4, therefore it is missing the expression x plus 3. So what I'm going to do, I'm just going to multiply x plus 3 on the top and x plus 3 on the bottom. Let me move on to my next one. Oops, sorry, it's supposed to be a negative. So minus 1 over x plus 3. On the second term, I have an x plus 3. What am I missing? I'm missing the expression x minus 4. So let me multiply x minus 4 on the top and the bottom. X minus 4 on the top, x minus 4 on the bottom. And what am I missing on the last term? Well, notice that the last term, it already has the LCD, x minus 4 times x plus 3. So therefore, there is nothing that is needed to be done on that last term. So let me just rewrite it the way it is. So 28 divided by x minus 4 times x plus 3. One thing to notice is that I'm not going to multiply the denominators. I'm just going to keep it as its factor form because they're going to cancel out. So why spend some time multiplying? All right, so now that I have that, let's simplify it. Let's distribute the first one. So now I'm going to have x squared plus 3x all over x plus 3 times x minus 4 minus, distribute that, so now becomes x minus 4 divided by x plus 3, x minus 4, and on the right hand side I just have a 28. So now I have x minus 4 and x plus 3. So again, notice that this negative right here, it is affecting the whole fraction. It is not just affecting this x. So therefore, all this is going to do is just going to change the sign of everything that is in the numerator. So now I have x squared plus 3x minus x plus 4 all over x plus 3, x minus 4, and that is equivalent to 28. X minus 4 and x plus 3. And now notice that they have the same denominator, so they're going to cancel out. And if they're going to cancel out, let me just keep simplifying the left-hand side. So if I work on the left-hand side now, I can see that I can combine those x's. So I have x squared plus 2x plus 4, and that's equivalent to 28. And notice that this equation can be solved faster than what we had initially. So I'm just going to be solving this now. To properly solve this quadratic equation, let me set it equal to 0. So I got minus 28, cancels out. So now I have x squared plus 2x minus 24 equal to 0. So now since I want to solve for this, let me see if I can factor it out. Can I find that two numbers that if I multiply gives me negative 24, and if I add them up gives me positive 2? Well, that's definitely 6 and 4. So we're going to have x plus 6 and x minus 4. So let's just double check this. 6 times negative 4, it is negative 24, so it checks out. And 6 minus 4, it is positive 2, so it checks out. So now that I have both factors to properly solve, I'm just going to set each one of them equals to 0. Take away 6, x equals negative 6. I got one possible solution. Add 4, x equals 4. I have another possible solution. And notice that I'm using the word possible because I got to check for extraneous solutions. So let's check the value of 4. Let's check if we have an extraneous solution at 4. But notice that if I take a look at the value of 4 and I plug it into the first denominator, that's going to give me a 0 in the denominator. So therefore, I cannot consider this a solution. This is an extraneous solution. So therefore, I'm not going to take it in consideration. So how about negative 6? Well, negative 6, if I plug it into the first fraction, the denominator of the first fraction, it doesn't give me 0, so it's good. To the second fraction, it doesn't give me 0, so it's good. To the last fraction, notice that it's the same as here. If I plug in negative 6, it doesn't give me 0 in the denominator, so it is good. So therefore, my only solution is the value x equals negative 6. And with this, it concludes our lesson for solving rational equations.